which is actually shared to us. So we have the first four, 180, VT, P, VAP and RH. These are all the features, and P, this is nothing but the target. So first four features are called as independent variable, and this is the electrical energy output. P is nothing but the dependent variable which we need to predict it. So, so in the data set we had total of 9,568 readings, and from the data we could see these four are the independent variables, and this is the dependent variable. And the applicable machine learning which we need to use is the supervised learning, because we have the data which is already labeled, and the algorithm which is applicable is regression, because all the x and y variables are linear in nature, which are also continuous in nature. So also we have more than one x variable, so complex linear regression is the algorithm which is actually we need to apply here, and the corresponding error metrics for the performance of the model which we need to use here is regression error metrics. And under this you can see mean square error, mean absolute error, mean absolute percentage error, and R square. These are the four performance metrics which we are going to use it. And for example, to find the predicted target variable, this is the formula. Why? So we have four input variables. The formula could be m0 plus m1 into x1 plus m2 into x2 plus m3 into x3 plus m4 into x4. So y is a target variable where m0 is the y-intercept, and m1 to m4 is the slope of x1 to x4, and x1, x2, x4 is nothing but the features. In the data preparation, so our assignment, what it says, we need to follow some approach to build a model and to test it. So currently I had considered an approach where we will be using the same algorithm with two different approaches. So first algorithm I'll be using first approaches we'll be using the same regression complex linear regression algorithm with four features, and we'll be predicting the target y. And the next approach we'll be removing one feature which is having the least coefficient, and the remaining three features we'll be taking up, and we'll be using the same algorithm to build the model. So the dataset will be, as per the recommend, the dataset should be divided into 80% for training set and remaining 20% test for the test set for the model evaluation. So these are the two approaches which I told you. So for the both approaches, once the model is built, we will be using the remaining 20% test data to evaluate the performance of the model, and we will be calculating the error matrix finally to identify which is the best approach to consider. I mean, which is the best model which is giving us the maximum output. I mean, the predicted variable should be as much as close to the actual variable. So the total observation is 9568, and 80% data from the 9568 is 7654, and the 20% data is 1914. So the next modeling approach one, if you see here I would have taken the 80% data set from here. So we will be having only 7,654 readings from the starting one to the 7,654. And here this regression statistics I had calculated with the help of Excel inbuilt formula, which is actually used for regression. So from this summary output, we could see here is the regression coefficients for intercept AT, V, AP, and H. Out of these, if you see now, AT, ambient temperature, which is actually minus 1.99, so this is the least coefficient. So in the next modeling approach, I will be removing this coefficient and I will be calculating the same coefficients here. So the next one, if you see here, I had removed the AT, ambient temperature, and I had again calculated the regression statistics here. Finally, you could see the coefficients for this particular three features. Considering the three features, these are all the coefficients value. And again, we are using the same 80% data set here, the same data set what we used in the previous approach one. Then if you see the evaluation approach for the first approach means, so you could see here the lots of data. So I had calculated finally, these are all the calculations which I did internally with the help of the formula from the for the MSE, MAE and MAPE for the R square. Finally, we are getting R square as 0.94, and if you see here the 20% data set which is not actually trained in the modeling, so I had used the remaining 20% set as a test set, and this is the predicted output values for the approach one. And the next sheet you can see here is I had used the second approach, and I had calculated the R square value and the other MSE, MA and MAP. The R square here contributes as 0.808. Here also the remaining 20% test data is used as an input to predict the values of MAE, MSE and MAPE and R square. So finally, as a result, if you see now from the both approaches, the R square value, this seems to be 0.94 and this is 0.808. So finally, to conclude a model, we should consider the R-square value. General assumption is it should be close to 1.0. So if we see both approaches, R-square for the approach 1, it's almost 0.94, which